Welcome to Intelligence Gateway.
User Authentication and Access Controls, Lecture 16.9. Describe how user authentication and access controls can be used to secure IT systems. User authentication and access controls are essential security measures that protect IT systems and sensitive data from unauthorized access. In short, user authentication verifies the identity of users before granting access to the system. Common methods include usernames, passwords, multi-factor authentication (MFA), and biometrics. Prevents unauthorized individuals from accessing the system, reducing the risk of data breaches. Access controls determine what resources and data users can access based on their roles and permissions. Types include discretionary access control (DAC), mandatory access control (MAC), and role-based access control restricts user access to specific data, ensuring data confidentiality and integrity. Together, user authentication and access controls provide a layered defense, reducing the chances of unauthorized access and enhancing the overall security of IT systems. Explain why the different methods of authentication and access controls would be used. The different methods of authentication and access controls are used to enhance IT system security and protect sensitive data based on specific requirements. In short, username and password authentication. Simple and widely used method, used for basic security needs, but susceptible to password-related vulnerabilities. Multi-factor authentication (MFA) adds an extra layer of security by requiring multiple forms of identification, used when higher security is essential, such as accessing sensitive data or critical systems. Biometric authentication uses unique physical traits for verification. Fingerprint, facial, iris scans deploy when stronger authentication is required to prevent identity fraud. Discretionary access control (DAC). Data owners control access to their resources. Suitable for small-scale environments where data owners can manage access rights. Evaluate how effectively different user authentication methods and access controls secure IT systems. Username and password authentication. Effectiveness: moderately effective for basic security needs, but susceptible to password-related vulnerabilities like weak passwords or password reuse. Enhancing password policies and educating users can improve its effectiveness. Multi-factor authentication (MFA). Effectiveness: highly effective in enhancing security. By requiring multiple forms of identification, provides strong protection against unauthorized access, especially for critical systems and sensitive data. Biometric authentication. Effectiveness: highly effective due to unique physical traits, making it difficult to forge or impersonate. Offers a high mandatory access control (MAC). Effectiveness: highly effective for high-security environments where access is tightly controlled. Based on predefined labels and clearances, provides strong protection against data exposure. Specification coverage. User authentication. User login procedure: strong password, text, and graphical password. Biometric authentication: two-step verification. Security tokens, including USB-based and near-field keys. Knowledge-based authentication, including question and response pairs. Kerberos network authentication for Windows and Linux-based operating system. Certificate-based authentication. Access controls and the methods to restrict users' access to resources, including applications, folders, files, and physical resources. User login procedures. Standard login procedures that require users to provide a username and password to access a system. Strong passwords. Enforcing password policies that require complex and lengthy passwords, reducing the risk of password-based attacks. Text and graphical passwords. Alternative login methods that use text or images as passwords. To enhance the security against traditional brute force attacks, biometric authentication, using Unique, physical characteristics like fingerprints, facial recognition, or iris scans to verify a user's identity. Two-step verification, requiring users to provide a second authentication factor, such as a one-time code sent to their mobile device for added security. Security tokens, devices like USB-based or near-field keys that generate one-time passwords or act as a second authentication factor. Knowledge-based authentication, asking users to answer specific questions or response pairs as an additional layer of verification. Kerberos network authentication, a network authentication protocol for Windows and Linux, based OP. Rating systems, providing secure authentication for network resources. Certificate-based authentication, using digital certificates to verify a user's identity, commonly used in SSL, TLS connections. Introductory task. Have you ever heard of the term user authentication? How do you authenticate yourself in order to gain access to the network at your center? Your phone. What other devices do you have where you have to authenticate yourself? User authentication is the process of verifying the identity of a user before granting access to a system or device. Authentication methods can vary based on the specific network or device being used. For example, network at your center, users may authenticate by providing a username and password. Using multi-factor authentication MFA with the ONI time code. Or biometric verification, your phone. Authentication methods on a phone may include PIN, pattern, password, fingerprint, or facial recognition. Other devices where users commonly authenticate themselves include laptops, tablets, online services, accounts, cloud storage services, and smart home devices. In short, user authentication is an essential security practice used to protect data and ensure that only authorized individuals can access networks and devices. Various authentication methods are employed, depending on the specific device or system being used. Deeper learning activities. Describe what is meant by the term user authentication. User authentication is a security process that verifies the identity of a user trying to access a system, network, or application. It typically involves the user providing credentials, such as a username and password, or using other methods like biometrics or multi-factor authentication to gain access. The purpose of user authentication is to ensure that only authorized individuals can access sensitive information and resources, protecting against unauthorized access and data breaches. Security tokens. Knowledge-based authentication. Kerberos network authentication. Suffix-based authentication. User login procedures. Standard process requiring users to provide a username and password to access a system or application. Strong password. A robust and complex password that is difficult to guess, enhancing security against unauthorized access. Text and graphical password. Alternative login methods using text or images as passwords for added security against traditional attacks. Biometric authentication. Verification using unique physical traits, fingerprint, facial, iris to confirm a user's identity. Two-step verification, requiring an additional authentication factor, like a one-time code sent to a mobile device for heightened security. Security tokens, devices generating one-time passwords or acting as an additional authentication factor. Knowledge-based authentication, users answering specific questions as an extra layer of verification. Kerberos network authentication, a network authentication protocol for secure access to resources in Windows and Linux systems. Certificate-based authentication, using digital certificates to verify user's identity, commonly used in SSL, TLS connections. Research and explain why each type of user authentication would be used and evaluate how effectively they secure an IT system. User login procedures. Use simple and commonly used method for basic security needs. Effectiveness. Moderately secure but vulnerable to password-related attacks. Like brute force attempts, not the most secure option on its own. Strong password. Use to enhance security against password-based attacks. Effectiveness. Effective when users create complex and lengthy passwords. However, human tendency to reuse or forget passwords can undermine its effectiveness. Text and graphical password. Use alternative login methods for added security against traditional attacks. Effectiveness. Moderately secure, but may be susceptible to shoulder surfing or pattern recognition attacks. Biometric authentication. Use high security authentication using unique physical traits. Effectiveness. Highly secure, as biometrics are difficult to forge or replicate, providing strong protection against unauthorized access. Two-step verification. Use adding an extra layer of security beyond passwords. Effectiveness. Highly secure, as it requires an additional authentication factor, reducing the risk of unauthorized access. Security tokens. Use generating one-time passwords or acting as an additional authentication factor. Effectiveness. Highly secure, especially when combined with other authentication methods, making it challenging for attackers to compromise knowledge-based authentication. Use asking users to answer specific questions for added verification. Effectiveness. Moderately secure, but some questions may have publicly available answers or be susceptible to social engineering. Kerberos network authentication. Use secure network authentication for Windows and Linux systems. Effectiveness. Highly secure, as it uses encryption and mutual authentication, reducing the risk of network-based attacks. Certificate-based authentication. Use verifying a user's identity using digital certificates. Effectiveness. Highly secure for secure connections like SSL, TLS, ensuring data integrity and user authenticity. Create access control. Create access control governs who can create or add new files, folders, or resources to a system. Effectiveness. Create access control plays a vital role in data security, preventing unauthorized users from adding potentially malicious content to the system. Edit access control. Edit access control determines who can modify existing files, folders, or resources without full write privileges. Effectiveness. Edit access control is useful in situations where limited modifications are allowed, helping prevent unauthorized changes to critical data. Delete access control. Delete access control governs who can remove or delete files, folders, or resources from a system. Effectiveness. Delete access control helps protect data from accidental or intentional deletion by limiting this privilege to authorized users only. Access control stesker. What is meant by the term access control? Access control is a security mechanism that regulates and manages user permissions and privileges to access specific resources, data, or services within a system, network, or physical environment. It ensures that unauthorized users can access the appropriate resources, protecting sensitive information and preventing unauthorized access or misuse. Access control stesker. What is meant by the term access control? Explain why an organization may want to restrict access to the following areas. Applications. Restrict access to applications to prevent unauthorized users from manipulating sensitive data or making unauthorized changes. Protects critical software from potential misuse, malware, or unauthorized modifications. Ensures that only authorized personnel can use specific applications, maintaining data integrity and system stability. Folders and files. Restricting access to folders and files prevents unauthorized users from viewing, modifying, or deleting sensitive information. Safeguards confidential data, intellectual property, and other critical resources from unauthorized access or data breaches. Physical resources. Restricting access to physical resources, like server rooms or data centers, prevents unauthorized entry and tampering. Protects valuable hardware, networking equipment, and sensitive data stored on physical devices, reduces the risk of theft, physical damage, or unauthorized Modifications to essential infrastructure. Describe what is meant by the following access controls and evaluate how effectively they keep data secure. Read access control. Read access control determines who can view or read the content of a file, folder, or resource. It restricts unauthorized users from accessing sensitive information, ensuring data confidentiality. Read access control is effective in preventing unauthorized users from viewing or reading sensitive data. It helps maintain data privacy and confidentiality. Write access control. Write access control governs who can make changes or modify the content of a file, folder, or resource. It prevents unauthorized users from altering critical data, reducing the risk of unauthorized traffic. Effectiveness. Write access control is crucial in safeguarding data integrity. It ensures that unauthorized individuals can make changes, reducing the chances of data tampering or unauthorized traffic. Trusted computing. Describe what is meant by the term trusted computing. Trusted computing is a concept in computer security that focuses on creating a secure and trusted environment for computing devices and systems. It involves hardware and software technologies that ensure the integrity, confidentiality, and authenticity of data and processes on a computer. Trusted computing aims to protect against various threats, such as malware, unauthorized access, and data breaches. By establishing a trusted computing base and securely managing cryptographic keys and operations, in short, trusted computing seeks to build a foundation of trust and security in computer. Seeks to build a foundation of trust and security in computing environments, providing users with confidence in the integrity and security of their data and operations. Progress check.
Thanks for watching. For more information, like, comment, and subscribe our channel.